So there are two things we want to understand about this spreadsheet. Firstly, what exactly do these numbers represent? What's the definition of the series we are looking at? And what is the meaning of these columns here in the back, which are not obviously representing particular months? So let's start with the meaning of the actual value. So what does the meaning of negative 0.57 means for January 1880? For that, we need to go back to the website where we got the data from. That's the Goddard Institute for Space Studies website. Our data file we downloaded from down here. And you may have to do a little bit of reading of this website, but there is a handy frequently asked question. And the first question here is the question that will deliver the answer to our question: what are temperature anomalies and why prefer them to absolute temperatures? Because the temperatures we have in our spreadsheet are indeed temperature anomalies. So let's quickly look at this. Here's the answer to this question. I encourage you to read this through. But just for starters, temperature anomalies indicate how much warmer or colder it is than normal for a particular place and time. Normal always means the average over the 30-year periods, 51 and 80 for that place and time of the year. So they basically use these anomalies because they have sensors all over the globe, and what they want to know is whether a particular sensor at a particular place, so the temperature has increased over time. So they define this reference period from 51 to 80, and then they can measure whether in that particular place the temperature has increased or decreased. It's also important to know that when we read, and that's not immediately obvious from this little paragraph, I have to admit, but I just know when it says negative 0.57, then the temperature was negative 0.57 degrees colder in January 1880 as compared to January of the reference period. Okay, and recall the reference period was 1951 to 1980. Okay, so that's why we'll later see no apparent seasonal pattern from across these months, because the reference period is the particular month and not the entire years 51 to 80. So secondly, what we want to figure out is what these columns here represent: J to D, D to N, DJF, MAM, JJA, and so on. Now, if you are observant, you will realize that these letters here possibly represent months. MAM, for instance, March, April, May. JJA, June, July, August, September, October, November, and DJF, December, January, February. So let's try this out. MAM, negative 0.26. So we will try, our conjecture is now that this value, let's compare this to these three values. What we're going to do is I'm going to hide a few columns here, and then we can make this bigger. So MAM, March, April, May. We're going to look at these three values, and we're going to compare this to this green value. And one conjecture would be that this value is the average temperature anomaly of these 3 months. So let's try that. Average of these 3 months. And indeed, we see that this value is exactly the same as this. And we could copy this a little down, and we could see that now these green values here are exactly the same as the values which we calculated using the monthly data. So these match everywhere. There's just some rounding going on here. Okay, so it means we understand these data. JJA will then of course be June, July, August, September, October, November, and so forth. So lastly, January to December is therefore most likely the annual average. So we will now compare January to December and see whether that is the average of all these 12 months. So we will again use our average function, and we highlight all these 12 months. We close the parenthesis, and we see we get negative 0.33667, which rounded is negative 0.34. So that means we now understand what these numbers mean. So here we have, this will be a particularly useful column. This is the annual average temperature anomaly. And you can see we have missing data because for this we would require, or this for instance, December of the previous year, but we don't have that observation. That's why we have some missing observation here.